Hey, so in this fairly informal video about Zuplo and rate limiting, I want to show you just how easily, or actually how dynamic you can make rate limiting for your API. So when we talk about dynamic rate limiting, we often talk about the idea of when we're rate limiting, we often do it by IP address or by user. But in real world scenarios, you need to set up different rate limits based on different users. You know, your premium customers might have 10,000 requests per minute, whilst your free customers only get 100 requests per minute. So that's what we talk about when we talk about dynamic rate limiting. But because Zuplo is a serverless programmable API gateway, you can actually make the rate limiter do anything you like. And in this example, what I'm going to do is I'm going to make the rate limiting so dynamic that it reads the rate limits from a database. In this case, we're actually going to use Supabase as our database. It's just super convenient, super easy to use, and we actually ship the Supabase SDK inside Zuplo as well. And so we're going to be able to change the values of the rate limits in the database, and that will show up in the activity we see in Zuplo. So to think about this a little bit more clearly, here's how we're going to build this. So your clients are over here, and they're going to be calling into Zuplo, which will forward requests onto your backend. I'm just using Whimsical here to do some simple diagramming. And what we want to do is inside the rate limiter that sits inside Zuplo, we're going to look at what group each user belongs to and read what the rate limit should be from Supabase. Now, the problem with that is that even though Supabase is really fast, it's still going to add quite a bit of latency to every request, which we typically don't want to do. So what we're actually going to do is store the results in the ZoneCache inside Zuplo. The ZoneCache is a cache that lives inside the data center. You know, we're an edge serverless gateway, so there are over 250 data centers that we deploy Zuplo to. That ZoneCache is extremely quick, a couple of milliseconds for a call typically, and can really increase the performance in scenarios like this. So the flow will be as follows. A client comes in. The client will be calling with an API key. That API key will have some metadata associated with it that will tell us whether they're in rate limiting group A or group B, for example. We will then check the cache to see if we have the rate limits available to us. If not, we'll go to Supabase, load in the rate limits, and then we'll apply them appropriately before forwarding on the request. For the next request that comes through, again, we'll have the user based on the API key. We will look at the group that they're a member of, and we'll check to see if we have something in the cache. And if we do, great. We'll just use that, apply the rate limits appropriately, and go on to the back end. So if we look in Supabase, we have a simple table called rate limits. Very easy. You can see it has a user group, group B and group A, and group B has 3 requests per minute and group A has 1 request per minute. And we're going to show you just how quickly you can change that. And then if we go back to Zuplo, actually you'll see that we have, where have I gone here? I'm in the wrong account. Here we go. If we go back to Zuplo, you'll see that we have some API key consumers here. I've called it key group B and key group A. And if we look at those, you'll see they just have some metadata that says the rate limit group. So you get it. This key group A is going to get 1 request per minute based on the current settings. And key group B is in group B, so it's going to get 3 requests per minute based on the current settings. I've already created some tests here for group A and group B. And then if we go and take a look at our routes, you'll see we have a simple route here. I'll call that test. And it has a policy. It has API key policy. I don't need that second one. It has an API key auth inbound policy here. Just a standard API key auth policy that will work with those 2 API consumers that I just showed you. And it has a rate limit policy. Now this rate limit policy is a little bit special. It has a default here of 2 requests allowed per minute, but it's using the function mode. And so in the function mode, what we do is we specify a module and an export from that module that we want the rate limiter to call. So we've got some custom code in play here. So let's go and take a look at that module. Here it is, and I'm going to walk you through the code. What I've done here is created some fallback limits. This is just the limits we're going to use if something goes wrong calling the cache, or something goes wrong calling which is very rare, but something goes wrong calling Supabase. I'm sure that's also rare. then you kind of probably don't want to take your API down just for the sake of rate limiting. So in that case, let's come back with some sort of sensible fallback. So, I've put 10,000 requests per minute here. You might choose something completely different. Then we look inside this getRateLimit function. This is asynchronous, so I can actually make database calls, or API calls rather, to Supabase in this case. And then this is the function that's going to get called by that rate limiter on every request. This will be called. So the first thing we do is we create an instance of a new cache object with a cache name, and we just pass in the request context. And then what I'm going to do is read the cache to see if I have stored away the rate limit groups in my cache. Also, I'm going to extract the user group from the incoming user. So remember that metadata that we put in the API key consumer that was rate limit group? We're going to grab that so it's handy. So if cached has a value, I'm going to do a little log that says we had a cache hit, and then I'm going to scan the data. So what we're actually storing in the cache is a list of items. You might choose to store a single item, or you might choose a different approach, very easy. But in this case, I just decided to throw all of the groups into one cache item. But you could create a cache item per group if you liked, per row in the Supabase database. The code is very simple. I'm sure you can work it out. And then what I'm going to do is find the row where the user group matches the user group on my user. And so that's called item. And then I'm going to take this limit response here, where I've basically I've just created a clone of the fallback limits object here using the spread operator. And what I'm going to do is I'm going to set requests allowed to the request per minute coming out of Supabase, and I'm going to return that to the rate limiter. So this is the fastest path. This means we read from the cache crazy quick. We tell the rate limiter how to think about this user when rate limiting, and then we're off. Now, if there was nothing in the cache because the cache entry expired, I'm going to log that we had a cache miss. I create an instance of the Supabase client. I'm going to invoke and read from the rate limits table. In this case, I'm reading everything. You might choose to do a query that just reads for a specific user. That would be as simple as adding a filter for the user group property here. And then I'm just going to check if there's an error. If there's an error calling Supabase, I'm going to log that so that I can work out what's going wrong and monitor that through our Datadog integration or similar. And I'm going to return my my default limit response. I haven't changed it at this point. I'm just going to return that fallback. Then I'm going to, if there was no error, I'm going to scan the data to find the particular user group I want again. And I'm going to do the same, essentially the same thing I did at the top. I'll do that down here where I set the request allowed to the request per minute. But here I just have another safety check. And that is, what if for some reason this user group wasn't in the database? Well, I should probably log that as well. So I say, if I didn't find an item in the set of results that came back, then I'm going to log a warning. Maybe that's not as bad. Maybe you don't expect to have all of the rows in the database. This will be your design. Then I return the fallback response again. But importantly here, if I get to this point, I found my item. I'm happy with how this is all working. I'm actually going to put the data that I actually got out of Supabase into the cache using the same cache key. In this case, I've said 60 seconds. That isn't going to make for a very good demo. I'm going to have to make you wait for 5 seconds for the cache to flush when I'm updating it. So we'll just do it. Let's do it for 10 seconds. So I will save that change now, and this will be live. And then what we can go and do is test this in action. So I'm going to go back to my test client, and we're going to do some requests on test A. I've already set the key for group A here. And if you remember, when I look in here, group A gets 1 request per minute. So what we should see is I do 1 request. I got a cache miss, if you look in the results there, which I'd expect. Then I'm going to do another one, and I get 429, too many requests, and this time I had a cache hit, which I'd expect, right? Because it was right into the cache. So from now on, for the next 5 seconds, these are going to be really fast, and then 1 request every 5 seconds might be a little bit slower when it calls Supabase. That's how you want to think about tuning that time in cache. How quickly will you need to be making changes? I think actually you might make this a long cache item, actually put it in for a number of minutes, but the choice is yours. If we look at a group B user, I would expect to hit this now, and I got a cache miss because it took me more than 10 seconds talking to you for for me to make this request, but this user should get 3 requests per minute, right? So let's see, 1, 2, 3, and then 4, 429, too many requests, exactly as expected. Now what's going to be really cool is to be able to dynamically change the rate limit. So I'm going to go in here, I'm going to change this to be, let's change it to be 5. So group A will now get 5 requests per minute. I just need to wait a few seconds to make sure that that cache expires so that we get a cache miss. I'm going to go to group A, and what we'll see is that when we hit it, I got a cache miss, which meant we've reloaded the data from Supabase. And so before it used to be 2 requests and this would be dead. 2, 3, 4, 5, and then 6, we get a 429, too many requests. That is just how dynamic the the rate limiting in Zuplo can be. Have fun.